Hello, and welcome to this 13th set of problems on arithmetic progression, geometric progression, and harmonic progression. So, as always, I'll say this that when I'm reading the problem, you should pause the video, and if you cannot solve the problem yourself, only then look at the solution. So, without further delay, let's get started. Problem 121 says that the sum of first 10 terms of an AP is equal to 155, and the sum of first two terms of a GP is 9. Find this progression if the first term of the AP equals the common ratio of the GP and the first term of GP equals the common difference of AP. So we let A to be the first term and D to be the common ratio of AP. So according to the question, D will be the first term and A will be the common ratio of the GP. Now it is given that 155 is sum of first 10 terms. So 155 is equal to 10 by 2 into 2A plus 10 minus 1 into D. So 10 by 2 is 5 and we divide 155 by 5, we get 31. So we can write 2A plus 9D is equal to 31. Now it is also given that sum of first two terms of geometric progression is 9. So it would be D plus AD is equal to 9. So we have two equations and two unknowns. We solve them. We get A is equal to 25 by 2 and A 2. So we follow this. We get D is equal to 2 by 3 and 3. So we will have two ratios, uh, two progressions. Arithmetic progression would be 2, 5, 8 and so on when A is 2 and D is 3. And when A is 25 by 2 and D is 2 by 3, the arithmetic progression would be 25 by 2, 79 by 6 and 83 by 6. And the GP would be similarly 3, 6 and 12 or 2 by 3, 25 by 3, 6, 25 by 6 and so on. Problem 122 says that if A, B, C, B in HP, prove that 1 by A plus 1 by B minus 1 by C multiplied with 1 by B plus 1 by C minus 1 by A is equal to 4 by AC minus 3 by B square. So since 1 by A, 1 by B, 1 by C are in AP because A, B, C are in HP, we can write that 2 by B is equal to 1 by A plus 1 by C, that is B is equal to 2AC by A plus C. Now this implies that 3 by 2 minus 2 by C is equal to 1 by A plus 1 by B minus 1 by C. So we take this and we subtract minus 2 by C on both sides and we add 1 by B. So we arrive at this result. Similarly, 3 by B minus 2 by A is equal to 1 by B plus 1 by C minus 1 by A. So what we are expected to solve for can be written in terms of 3 by B minus 2 by C into 3 by B minus 2 by A. So we evaluate this and it turns out to be 9AC minus 6AB minus 6BC plus 4B square by ACB square. Now 9AC by ACB square will result in 9 by B square. 4B square by ACB square will result in 4 by AC, and 6AB minus 6BC can be written as minus 6B into A plus C by ACB square. Now here we substitute the value of B from this. We get this as 2 by B and AC remains same. Now AC should be cancelled out here. AC should not be here. Once we have this, we see that this is 12 and B will get cancelled, B square will remain. So this is 12 by B square. 9 by B square minus 12 by B square is 3 by B square. This AC should not be here. A plus C by AC is equal to 2 by B from here. Problem 123 says that if A, B, C are positive real numbers which are in HP, show that A plus B by 2A minus B plus B plus C by 2C minus B greater than or equal to 4. So we are given that A, B, C are in HP, so 2 by B is equal to 1 by A plus 1 by C. And we are supposed to find out the value of A plus B by 2A minus B plus B plus C by 2C minus B. So we divide numerator and denominator of the first term by AB. We get 1 by B plus 1 by A divided by 2 by B minus 1 by A. And we divide the second term by BC. We get 1 by B plus 1 by C is equal to 2 by B minus 1 by C. Now we substitute this value from here to here. So when you substitute, what will happen is this 1 by a will get cancelled, it will become 1 by c, and this will become 1 by a. So if it becomes 1 by c, you can take c to the top. So it will become c by a plus c by b. And you can take a to the top here, it will become a by b plus a by c. So this total is equal to c square plus a square by ac plus a plus c by b. Now what we can do is, this is easy. This remains c square plus a square by ac. For this term, we substitute b is equal to 2ac by a plus c. So this becomes a plus c whole square by 2ac. Now we subtract 2 here, and we add plus 4 to maintain the balance. So this becomes c minus a whole square by ac and a minus c by whole square by 2ac. Now these two terms would be greater than 0. So when we add this to 4, this whole thing will be greater than or equal to 4. Problem 124 says that if a plus b by 1 minus ab, b plus c by 1 minus bc are in AP, prove that a, b to the power minus 1 and c are in HP. So we write that middle term minus first term is equal to third term minus middle term. So we take LCM, we get this much, and here we cancel out b, here we cancel out b. So the left hand side is minus a into 1 plus b square. Upon taking a common here in between these two, divide by 1 minus b. And here we take c common, it becomes 1 plus b, c into 1 plus b square by 1 minus bc. We cancel out 1 plus b square, we get minus a into 1 minus bc is equal to c multiplied with 1 minus ab. So if you rearrange these terms, you get a plus c is equal to 2abc. That is 2b is equal to a plus c by ac. And then we can say that a, b inverse c are in HP. Problem 125 says that suppose a, b, c are in AP where modulus of all of them is less than 1. If x is equal to 1 plus a square up to infinity, y is equal to 1 plus b square up to infinity, and z is equal to 1 plus c square up to infinity, then prove that x, y, z are in HP. So x is equal to 1 by 1 minus a, y is equal to 1 by 1 minus b, and z is equal to 1 by 1 minus c. Now we are given that a, b, c are in AP. So 1 minus a, 1 minus b, and 1 minus c will be in AP. And therefore 1 by 1 minus a, 1 by 1 minus b, 1 by 1 minus c will be in HP. And this is equal to x, y, z. So x, y, z are in HP. Problem 126 says that if a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z, and a, b, c are in GP, prove that x, y, z are in AP. So we let a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z is equal to k. So a becomes k to the power x, b becomes k to the power y, and c is k to the power z. Now given that a, b, c are in GP, so b square is equal to AC. That is k to the power 2y is equal to k to the power x plus z. So we can say that 2y is equal to x plus z, and therefore x, y, z are in AP. Problem 127 says that if A, B, C, B in AP, L, M, N, B in HP, and AL, BM, CN, B in GP with common ratio not equal to 1, and A, B, C, L, M, N are positive, show that A is to B is to C is equal to 1 by N is to 1 by M is to 1 by L. So we are given that 2B is equal to A plus C, M is equal to 2 ln by L plus N, and B square M square is equal to AC ln. So we have written the relationship of middle term with the extremes. So from this, what we do is we write the value, we substitute the value of B and M over here. So it becomes A plus C by 2 into 2 ln by L plus N whole square is equal to AC ln. Now I cancel out 2, and then we will have A plus C whole square by L plus N whole square is equal to AC ln. So we take A plus C over here, and we take ln over here. So it becomes ln by L plus N whole square is equal to AC by A plus C whole square. This will be L square N square. So it will get cancelled with this ln to give us ln here. and this a plus c whole square we take to the denominator over here. So we reverse this and we write that a plus c whole square by ac is equal to l plus n whole square by ln. So if you follow this, then you can see that a by c plus c by a is equal to l by n plus n by l. So how this has come is, if you expand this, it becomes a square plus c square plus 2ac, and this becomes l square plus n square plus 2nl. So a square plus c square by ac is a by c plus c by a, and 2ac by ac is 2. Similarly here 2 plus 2nl by ln will be 2. So 2 will get cancelled from both sides, and l square plus n square by ln is l by n plus n by l. So once we have this relationship, we can say that a is to c is equal to 1 by n is to 1 by l. And now it's a matter of letting this to be equal to k and substituting the value of ac over here, and you will find that a is to b is to c is equal to 1 by n is to 1 by m is to 1 by l. Problem 128 says that find three numbers a, b, c between 2 and 18 such that their sum is 25. The numbers 2, a, b are consecutive terms of an AP, and the numbers b, c, 18 are consecutive terms of a GP. So we are given that sum is 25. So a plus b plus c is equal to 25. And then 2ab are in AC. So 2a is equal to 2 plus b. And bc 18 are in GP. So c square is equal to 18b. Now we can write from this term that b is equal to 2 into a minus 1. And from here we can write that c is equal to square root of 18b. Now we substitute the value of b from here. We get 36 a minus 1. 36 multiplied with a minus 1. We take out 6 outside, we get c is equal to 6 square root of a minus 1. Now we substitute this here in a plus b plus c. We substitute the value of b as well. We get a plus 2 into a minus 1 plus 6 square root of a minus 1 is equal to 25. This 2a plus a will be 3a, and this will be minus 2. So yeah, so now we have 3a minus 2 plus 6 square root of a minus 1. We take 2 this side, it becomes 27. And now on left hand side we will be left with 3a plus 6 square root of a minus 1. So we divide by 3, we get a plus 2 square root of a minus 1 is equal to 9. So from this you can take a this side and then square both sides and solve the quadratic equation. You will obtain two values of a, 17 and 5. However, if a is 17, then b becomes 32, which is greater than 18. But the numbers are between 2 and 18, so this cannot be the solution. So a must be equal to 5. If a is equal to 5, b will be 2 into 5 minus 1, that is 8. And c would be square root of 18 into 8, that is square root of 144, that is 12. Now problem 129 says that if a, b, c are in AP and a, m, b, c are in GP, prove that a, m square b comma c are in HP. So from first two we can write that 2b is equal to a plus c and m square b square is equal to ac. So here we take m square b is equal to ac by b. Now we substitute the value of b, that is a plus c by 2. It becomes 2ac by a plus c. Now if you observe m square b is equal to 2ac by a plus c, it is the relationship of the midterm of an HP. So a, m square b, c are in HP. Problem 130 says that if an AP, a GP and an HP have the same first term a, they should be and same second term b, so that n plus 2th term will be in GP is b to, if they should be if b to the power 2n plus 2 minus a to the power 2n plus 2 divided by ab multiplied with b to the power 2n minus a to the power 2n is equal to n plus 1 by n. So common difference of AP would be b minus a. Common ratio of GP would be b minus a. And the common difference for the corresponding HP would be a minus b divided by a minus b, because it would be 1 by b minus 1 by a. That would be equal to a minus b divided by ab. Now n plus 2th term of AP would be a plus n a plus 1 into b minus a, that is n plus 1 into b minus na. Similarly, n plus 2th term of GP would be AR to the power n plus 1, that is equal to b to the power n plus 1 divided by a to the power n. And similarly, n plus 2th term of HP would come out to be AB by n plus 1 into A minus NB. Now these three will be in GP if this multiplied with this, which is here, is equal to square of this, that is b to the power 2n plus 2 by a to the power 2n. Once we have this, we cross multiply, we obtain this. Then we take out certain terms, that is we take this term, we take this term on one side, and we take this term and this term on the second side. And after that we take out n plus 1 ab square common and here nb common, and then we have the desired result. With this we come to the end of 13th set of problem, and in the next set we will solve the 10 more problems. I hope you have found this video useful and informative. Please subscribe to the channel and like the video so that these videos can reach many more people and they can benefit from this. If you have a comment or a suggestion or a question, use the comment box to convey your thoughts. And thanks a lot for watching. Enjoy.